Hello guys. So here I'm Mohammed Zaid, and here we are about to speak about the topic mathematical modeling in data center service allocation. So in this heading, there are actually two main keywords. One is data center, and one is the mathematical modeling. So what are data centers are like they are the critical infrastructures which are they are the critical infrastructures for the organizations and the businesses, because they provide a computing power and a storage capacity which is needed to run the application, websites, and the other critical services which are needed in an organization. So as the data center grow in size and complexity, so the challenge of allocating resources to service becomes increasingly difficult. So, yeah, the other keyword which is highlighted here is the mathematical modeling. Mathematical modeling can be used to help the data center managers allocate resources more efficiently. So, by modeling the behavior of the data center, managers can identify the bottlenecks and optimize the resource allocations, and definitely improve the performance and it will definitely reduce the cost. So there are a number of different mathematical models that can be used for data center resource allocation. Some of the most commonly used models are queuing theory, genetics algorithm, and then machine learning. Machine learning, which is one of the famous technique. In this technique, it will be this technique is used to learn from the historic data and make the predictions about the future resource using the previous test case data. And then the genetics algorithm, these algorithms can be used to search for optimal resources allocation solutions. So for example, as the word genetics means from the past history, from the past what a trend or something like that. If one data center of the same type uses a specific algorithm, so the same data center of the same type will use the same algorithm, and this trend will pass on. So this is about the genetic algorithm. And then the queuing theory. So in this model, queue data structure is used. So this model is used to model the behavior of queues, which are used to manage the flow of request of data, basically, or the resources. So if you see in that way, mathematical modeling is a powerful tool that can help data center managers improve the resource allocation and optimize the performance very vastly. So, few benefits of using this mathematical modeling for the data center service allocations are: one is to improve the performance, to reduce the cost, and then to definitely to increase the what do you call the reliability. So like by identifying and avoiding the risks which are gonna occur in the way, we can definitely increase the reliability of the model. And then reducing the cost, mathematical modeling can help to reduce the cost of running a data structure, which this can be achieved by optimizing the resource utilization. And then the improved performance, by optimizing the resource allocation, the data can help to improve the performance of the data centers, which will definitely lead to the shorter response time. And then overall, if you see in that way, the mathematical modeling is a valuable tool that can help data center managers to improve the performance and etc., which you have already told before. And if you just see to the literature survey, uh, like from the past three types which I have already told you, the machine learning, genetic algorithm, and the queuing theory, we can actually tell the choice of mathematical model depends on the specific characteristics. For example, queuing theory is a good choice for the data centers that have like a large number of users, whereas a genetic algorithm is a like perfect choice for data centers that need to find the optimal resource allocation. whereas machine learning is a good choice for the data centers that want to learn from the previous history, like the historical data. So like if you just like look into the surveys done here, like there are few of the research papers that have been published on the topic of the same mathematical modeling in the, like the data center service allocation. These research papers provide a good overview, like the state of art, what is happening in the mathematical modeling. So they also discuss the challenges and the limitations of the different approaches, which will be like present or which will come on the way when we choose a specific model. So one of the famous research paper is a genetic algorithm approach to resource allocation in data centers, which was written by S. Wang and X. Zhang in 2011. So Abhi will overtake about the case study which is going on right.
3 2 1 start.
Now, let us see a case study of a service center location. Let's consider a telecommunication company with a large customer base who are spread throughout the world. So, the company wants to allocate service centers in an efficiently and timely manner that all the customers can be supported and helped. So, before allocating the service center, there are several things a company must do. Like the data collection is the primary thing. Company has to collect the customers' information, location, and also their demands, and also considering the data collected, it has to allocate the service centers optimally. There may be a resource minimization, like we cannot establish as many service centers as we want. We have to think about the cost factor. So the objective or the optimization is to reduce the distance traveled by the customer, or the minimum number of service centers that are to be allocated. So now let us consider an example of a service center location. We have five regions A, B, C, D, E, and the population of a particular region and the geographical area are given. So the region A has a population of 20 lakh and a geographical area of 500 square kilometers. Similarly, region B has so and so, region C and so and so. So if the company wants to allocate a service center for every 50 lakh population and 200 square kilometers of geographical area, then we divide the population of that particular region with the with the total population. So we get the number of service centers that are to be allocated based on the population. Similarly, service centers need that are to be established based on the geographical area. The geographical area of a region divided by the no geographical area of a region divided by the total geographical area of regions. So that will give the service center that are to be allocated based on the geographical area. So we get four three servers. Similarly, the total number of servers will add up to 14. So it's not only about geographical area and population. We have to consider the demand factors. So demand constant needs to be considered. So if the region A has a demand of 1,000 units, and region B has a 800 units, region C 1,020 units, region D 1,500 units, and region E 900 units. Then we add up the total demand. We After adding, we calculate the demand of that particular region with the total region. Here we the demand of region A is 1,000 and the total demand is the 5,400. So we get 0.1852. And the total number of service centers that are to be the number of service centers that can be allocated is 7. Like if the company have the resources to allocate only 7 service centers, then we can multiply the obtained number by 7, so it will be to 1.29, so it will be nearest to 1. So the company has to establish one service center near region A. Similarly, for region B, it will be one service center, and for region C, it will be two service center. So the service centers now has reduced to 7. In the first case, as you have seen, the total number of service centers was 14, 3 to 4 to 3, which adds up to 14. But in the second case, when we have limited our service centers or the service allocation centers, the service centers are minimized to 17, and the problem has been optimized. Similarly, if the Similarly, if we consider the distance between each server and region, then we can have a code which we can run. Like the demand for the regions is has been given here. Like the demand of np.array is given 1000, and region B is 800, and
Thanks,
region C is
sir.
1200, region D is 1500, and region E is 900. Similarly, the distance between region A and server 1 is 5,
Hot
region
sauce.
A and server 2 is 7, region A and server 3 is 8. Similarly, till up to 7. So we can again optimize this problem. Yes, so if you have only five service, if you have only five service centers, then we can optimize the problem by running this code. So we have given the distance between the regions and the service centers. So after running this code, the code gives us the region and the particular service center that are to be allocated and the distance between them. So this will help the company to optimize the problem, and to know where the service centers are to be allocated. So the customers can be more helpful, can be more helped. Okay. So let us consider the gap analysis. Gap analysis is nothing but the comparison between the current state and the goal state. Suppose we have a plan to execute a set of activities, and after
Orange,
executing a set of
orange
activities, we
banana.
need to compare with the current situation and the actual plan. This is you are on mute.
Hey everyone, my name is Yashas and I'll be doing the example for the topic. We'll be considering a general example. Uh, we'll take a scenario where data center is described as having two types of resources, which are basically servers and data storage. So servers are basically used to run the operations or applications, whereas storage is used to basically store data. Okay, so in an ideal scenario, we'll have enough servers and storage units for running an operation smoothly. But that's only possible in an ideal scenario. In real world applications, we have some limitations. So we are focusing more on the optimized solution, right? We are focusing more on the optimized number of requirements which we have, because we have a constraint on the number of servers or the quantity of storage what we have. To optimize the allocation of these resources, we can employ a mathematical model. So we'll make the analogy where a mathematical model represents is the representation of the real world system. And in this case, the data center, using the mathematical equations and variables, we can formulate a mathematical model which gives an optimized solution. Okay, which can be used for various scenarios for the allocations of these servers and data storage. Okay. This mathematical model aids in finding the optimal resource solution, which balances the performance requirements while is maintaining the required number of server and data storage. That is, the constraints and other parameters are satisfied. Furthermore, these mathematical models can be applied in real life. What I mean by that is the proper word to be used is dynamically applied. So, what happens is usually there's the number of constants or parameters are changing in such a way, like let's say the number of servers are to be reduced, or we get more number of servers. The storage requirements are less, or it increases, and these are let's say erratic, and we can't predict them. But what we can do is facilitate the enough resources or get back enough resources. For this, our mathematical model is dynamically adaptable. So at any time these changes occurs, our mathematical model dynamically adapts to it. Basically, by utilizing these mathematical modeling for a resource allocation in a data center, the decision makers can make informed choices based on the mathematical model solution on how to use the resources to get the required optimal results. We'll consider various examples, specific examples. So the first one is Google. So yeah, as we know, Google obviously uses a lot of mathematical modeling solutions because it's so vast. We'll take one similar example which we use basically every day, which is search algorithms. Okay, so we search anything on Google, we get hassle-free results. You don't have to worry about what's happening behind the screen because a lot of stuff happens behind the screens, and these are usually complex, right? We get a list of search results when we search something. These are not randomly popped up. These are the results of the mathematical model which is employed. Okay, what this does is it studies our behavior, our browsing behavior, and not just that, the quality of the page which is going to be popped up, right? And the relevance, the keyword relevance. If you type something, how relevant is it to it? So like this, it's gonna rank some results, and searching that, it will show thousands of pages which are ranked within a fraction of seconds. This can be only be done by mathematical modeling, which is quite vast, and it gives a really nice solution. There are a lot of things Google employs mathematical modeling. It can be advertising, so we get Google ads, right? These Google ads are brought by let's say the mathematical models. How they are brought by because of the parameters in the mathematical model. These are basically the browsing habits, the browsing behavior we do, the relevance of the ad based on the location or based on the previous searches, which is basically browsing behavior. This was just Google. We even see Amazon employing various mathematical models. In Amazon, it's a bit different because since it's a marketplace, it is basically e-commerce website. Uh, One such particular application where mathematical modeling can be used is supply chain optimization. So we just order something on Amazon, we get it, right? That's hassle free again for us. What's happening behind the screen, what's happening behind the scene is quite complex again. So there's a complex network, right? Thousands of people are ordering something, thousands of people are getting shipped. There are merchants selling things, right? So that's a very vast network, and it has to be managed. So not only these have to be managed, these have to give you an optimal solution, right? So an optimal solution regarding who gets what first, who gets what in what time, what gets sold first and what gets sold more, what items are to be displayed more, and what items are don't need that much of an advertisement. So mathematical modeling basically gives an output on these various parameters so that the products can be sold in enough time, giving both the customer the satisfaction of the product, the required product they needed, and the success of selling the product. There are so many other places also where Amazon uses mathematical modeling. To list few are warehouse management. So just to give a brief about it, warehouse management is nothing but how optimally can the warehouse be managed so that the products are kept. So basically, there are few products selling in a location B. You need not sell that in location A where some other product is selling. So you can't just randomly pop in the products in a random location, right? We have to study the behavior of how customers order, and this is what the model does. So it accounts in various parameters such as the uh, product's relevance, previous orders by the customers, and the efficiency of keeping the product in that warehouse because conditions, physical conditions matters, recommendation systems, fraud detection systems, and there are other various things Amazon uses. So we'll consider Netflix now. That's also another thing, right? So Netflix is basically content. It runs on content delivery network, which is CDN. So Netflix is a streaming platform. Again, it uses mathematical modeling. So one main application of it is quite famous, right? Recommendation algorithms. Netflix has a very good recommendation algorithm. I'm pretty sure a lot of shows you watch, a lot of things you watch, it's either someone told you or you just got bored and you just serve the recommendation page which you have. So how is it done? It's basically done by algorithms, right? These algorithms employ a mathematical model which also employs on its own various machine learning algorithms and various statistical data. So studying this based on the various parameters such as user preference, what they watch, because of the history, right? There are preferences and there's behaviors, there's patterns, right? They study the pattern, the machine learning algorithm studies the pattern, and it gives an optimal output, which is basically the recommendation page, right? So Content optimization. Content optimization is also required because again, Netflix is also a vast network. Right? There are so many streaming happening. All right. So what we see is hassle-free streaming, but then again, behind the scenes, there are various servers and data centers. Right. We have various servers and storage, which are basically data centers. So these data centers have to be operated smoothly in an optimal way so that they aren't overheaded, or any one data center is not at all used when it can be used, which has potential, right? So this mathematical model, what it does is factors in various parameters, right, such as network congestion, server capacity, and user demand, and various other network terminologies which describe how the pathway of the content delivery is done. So mathematical modeling, to summarize, in case of Netflix, it it improves the CDN, which is a content delivery network. It optimizes it and gives it optimal solution so that uh, given limited number of data centers, we get the desired output. We get the hassle-free streaming. That's it.
So, thank you, everyone. I guess this is the end. We have gained a lot of knowledge and the recent trends that is being going on in this mathematical modeling. So, that's it. Thank you, guys.
Thank you.